Lengths of legs of a right triangle are 15 and 20. What is the distance of the center of the inscribed circle to the altitude of the triangle drawn towards the hypotenuse? Look at the diagram. ABC is the right triangle with angle ACB, that is this angle, is 90 degree. Sides AC is 15, side BC is 20. O is the center of the inscribed circle. M, N and Q, that is M, N and Q, are the points at which the circle touches the sides of the triangle. CP is the altitude of triangle ABC from A to hypotenuse AB. That is, this is the altitude of the right triangle from C to P. This distance, that is AP, we will find out, and then we are required to find out the distance from O to CP, which is same as the distance of Q to CP, this distance. Because CP and OP are parallel, both being perpendicular to the hypotenuse AB. So, we shall find out AP separately and AQ separately and subtract AP from AQ to get QP. Now, the hypotenuse square, that is AB square, is equal to sum of the two legs of the right angle triangle squares, that is AC square plus CB square, and that is equal to, we know the values of AC and CB already, so AC square plus CB square is equal to 15 square plus 20 squared, and that is equal to 225 plus 400, and that is 625. Therefore, hypotenuse AB is equal to 25. That is, this is equal to 25. Now, area of triangle ABC is equal to half base into height, and this is height and this is base. So, area of triangle ABC is equal to half CP multiplied by AB, but area of the same triangle ACB is also half AC into BC because this angle is 90 degree. So, half CP multiplied by AB is equal to half AC multiplied by BC. Now, we know the value of AB, that is 25. We know the value of both AC and BC, that is 15 and 20. Therefore, we get 25 CP is equal to 15 into 20. So, we get the value of Cp as 15 multiplied by 20 divided by 25, and that is equal to 12. That means Cp, that is this altitude, is 12. Now, AP square, that is this square, is equal to AC square AC square minus Cp square. Why? That's because this angle is 90 degree. So, by Pythagorean theorem, this square minus this square is equal to AP square. Now, AC is equal to 15 and CP is equal to 12. Therefore, AP square is equal to 15 square minus 12 square, and that is equal to 225 minus 144, which is equal to 81. Therefore, AP is equal to 9. That means AP is equal to 9. We have now found out the value of AP. Now, we will try to find out the value of AQ and then subtract AP from AQ to get the distance PQ. Let us call the equation AP is equal to 9 as equation 1. Before going any further, please like, subscribe, share and hit the bell so you can immediately be notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. Now look at the diagram again. AC, AB and BC are all tangents to the circle from external points A, B and C. M, N and Q are points of tangency. We know from a theorem in geometry that if two tangents are drawn to a circle from an external point, then the lengths of the two tangents are equal. Now, CM is a tangent and CN is another tangent drawn from the same point C to the circle. Therefore, CM is equal to CN or MC is equal to NC. Similarly, tangent AM and tangent AQ drawn from N to the same circle also will be equal. Therefore, AM is equal to AQ. Finally, two tangents drawn from B, that is BN and BQ, are also equal. Now, AC is equal to AM plus MC. But AM is equal to AQ and MC is equal to CN. And we know the value of AC to be 15. Therefore, AQ plus CN is equal to 15. Similarly, BC is equal to BN plus CN and that is equal to BQ plus CN, and we know the value of BC to be 20. So, we get BQ plus CN is equal to 20. Now, these are two equations. If you add both sides of these two equations, we get AQ plus BQ plus 2CN is equal to 35. But AQ plus BQ is equal to AB. So we get AB plus 2CN is equal to 35. Now AB, we have found out the value to be 25. So we get 25 plus 2CN is equal to 35. Hence, 2CN is equal to 10 or CN is equal to 5. Now BN is equal to, that is this distance BN is equal to BC minus CN, that is the big distance BC minus this small distance CN, and that is equal to 20 minus 5 is 15. Or BQ, that is this distance, which is same as BN, and that is equal to, we have just now found out, is equal to 15. So SAQ will be AB minus BQ, and AB is 25, BQ just now found out to be 15, So AQ is equal to 10. Remember that we have to find out PQ, and PQ is equal to AQ minus AP, which is 10 minus 9. Remember, we had found out the value of AP to be 9 in equation 1. Therefore, PQ is equal to 10 minus 9, and that is equal to 1. So, this is the distance from the center of the incircle to the altitude of the triangle from A to the hypotenuse AB. And this is the answer. Thank you.